Thanks everyone for joining our geospatial webinar presented by Optron and myself, Sean, and my colleague from Trimble, Dennis Belgrado, will join as well a little bit later to show you some fancy things. Yeah, thanks again for taking the time. It's really good to have you guys here, and we are recording the session, so if so that people who didn't make it can of course watch a bit later, or you can review the session in your own time. Unfortunately, my camera is malfunctioned, so I won't be able to turn that on, so you won't be able to see what I look like. But you can look at my mugshot on the in the Teams. All right, let's jump in. Okay, so what we're going to cover today: mobile mapping. And just wanting to introduce. Oh, first of all, guys, if possible, you can mute yourselves. That would be fantastic. Feel free to ask a question anytime or drop something in the chat box. But yeah, try and keep yourself on mute if you can. That'll be good. All right. So what we're going to chat about today, we'll chat a bit about mobile mapping, and hopefully I can illustrate why it's such an amazing tool for the survey and mapping world today. We'll give you some insights into what mobile mapping is about. Why should we choose mobile mapping? We'll chat a bit about some workflows. We'll look at some data, and then my colleague Dennis will give us a live showdown, showing some data from a tunnel that we captured down in South Africa a couple of years back, and I think that'll be pretty exciting. And then we'll open up some questions and answers, and feel free to, as I said, to open in the chat box, drop a line, or wait to the end, and we can take your questions. All right, so myself, Sean Dane, I've been at Optron a long time. I'm the geospatial segment manager. I operate out of Durban on the east coast of South Africa. I'm a land surveyor by profession. I've been with Optron for almost 2 decades. In fact, it was my 18th year anniversary last month. So yeah, I've been in the industry 20 years and been working in mobile mapping and scanning and so on for at least the last decade. My colleague Dennis, we go back a long way. First met Dennis back in Dubai in 2004. He was actually my trainer. So everything I know today and present, he's taught me. What a legend.
Yeah, that's why here I stopped counting years, instead counting decades, because it's a little bit smaller number.
Excellent. Yeah, that's true. So yeah, Dennis, been in the industry a long time. 5 decades old. Oh, that's 5 decades young, Dennis. Originally, Dennis from the Philippines. He's based in Dubai at the moment. Been in the geospatial industry for 3 decades. 2 decades in the Middle East and Africa, dealing with all of us, and in mobile mapping for at least 1 decade. So we have a lot of experience and a lot of exposure to a whole lot of different aspects of the survey and mapping world between the two of us, and hopefully we can share some good things today. So we're trying to pitch this presentation at a very high level as more of an introduction into mobile mapping, and to continue the good of mobile mapping that is growing in the industry, and yeah, I'd really like to share some good things with you folks today. All right, so what is mobile mapping? At a very high level, mobile mapping is a process of collecting geospatial data using a mobile vehicle, and typically fitted with a range of sensors, LiDARs, cameras, IMUs, GNSS, and so on. And if you see in a couple of the images that I've got shared here, and we'll chat a bit more in detail around the components and applications and so on as we go on. But it's essentially a mobile survey tool, and we've got down to centimeter accuracy at not quite road speeds, but 30 k's an hour or so driving down the road. You can get pretty close to a centimeter absolute accuracy, which is fantastic. So this type of equipment is now becoming more mainstream, and survey and mapping companies and even utility companies and governmental municipalities and so on should absolutely be looking into this tech to be more efficient, effective, cost-effective? Absolutely, yeah. You have some high upfront costs, but over time, you're definitely more cost-effective with these types of solutions. I've got a quick video to play for the next one, so just bear with me. I hope that you can hear the sound. If you don't, then I don't know how to make it go, so I just hope you can.
No sounds, unfortunately.
Install within minutes and easily
I think
go
the sound should be on now.
Can take
Yeah,
you.
yeah, it's coming.
Cool, cool.
With world-class precision and total confidence. If you can see it, you can map it. Capture, process, extract, and share your data seamlessly. With intuitive workflows that keep your projects cruising at top speed. And plenty of blue sky. If you're ready to take control of your data, slash work time, and leave hassles in the dust, the Trimble MX50 is right on time and ready to roll. Let's take productivity on the road.
All right, so that was just a quick marketing video, and obviously people are like, oh, now it's another marketing video and so on. But I can honestly tell you that what you saw in that session, what we saw in that short clip of a minute, is true and real. The system's efficient, effective. The data you're getting is clear, and literally you're mapping at road speeds, driving down, capturing as much data as you possibly can. And then the beauty of these solutions is that you're actually doing all the good stuff in the office. So it's safe and so on. You can have your aircon on and all that. So yeah, fantastic pieces of kit from Trimble. All right, so in our portfolio today, we have a couple of systems, starting from the left-hand side, the MX90, which is recently released. It's a high-end flagship solution, dense point clouds, high accuracy, long range for survey and engineering primarily. In the middle of the road, we got the MX50, which is what you saw in the video. Dense point clouds, absolutely. High accuracy, let's call it a medium range. Also very effective in survey mapping and more pitched at the asset management part of the sector. The neat thing about this solution is it's a 100% Trimble system. So you'll notice on with the MX90 we got some Regal scanners here, but with the MX50 we have a 100% Trimble solution in there. Okay, excluding the camera, which is OEM. But the laser profilers are Trimble designed and built. The IMU and all the components designed and built and integrated by the clever folks from Trimble. On the right-hand side, the MX7, so that's an image-based solution only, so it's just a camera system with an IMU and more entry-level and imaging only. All right, we'll take a look on the right-hand side at the workflow a little bit later, but just to give you an interlude as to, you're capturing your data with the hardware in the field, pulling the data into Office software to process, and then from there you're extracting your deliverables and sharing with your customers, your clients, your colleagues as you go. So what does a mobile mapping system consist of? Here I've got an image of the MX50, but the components of all the systems you see are very, very similar. So on the MX50 yourself, you got your 2 laser scanners, you got a 360-degree panoramic camera. We've got an IMU, inertial measurement unit, inside with GNSS, and then racking systems and cables and so on. So that's pretty much the system, right? So you've got 2 lasers and an IMU plus imagery, and you're driving down the road. How to control it? You controlling it with your own device. You can literally control it with your mobile phone. If you have a large resolution screen, recommended 10-inch screen for you to effectively see the data and so on, but you can literally use any device. So we basically build a small Wi-Fi hotspot inside the vehicle with this control unit, and you connect to the Wi-Fi hotspot and you control your mobile mapping system. That's how easy it is. The power unit on the left-hand side, so we take power off the vehicle. There's no need for a whole lot of extra batteries and all that. You can take power off the main vehicle's battery. And your control unit, that's the brains behind everything. So your computer, your processing engine, all that is sitting inside the control unit. So yeah, that's one of the most important parts of making sure that you've got your data on removable hard drives and setting up the Wi-Fi in the LAN and so on. And then on the right-hand side, we have a roof rack and then some accessories. You also may need a DMI, which is a distance measuring instrument, and you'll utilize that in environments where you have limited GNSS and so on, and it plugs onto the side of onto the wheel, one of the rear wheels of your vehicle, depending on which side of the road you drive. You'll put it on either side that makes the most sense. I'm not going to spend too much time on this slide, but just to give you some idea of the specs and so on. So as I said, with the MX90, we've got 2 lasers and they're Regal scanners. You can have a quick look at the spec in your own time. MX50 also 2 lasers, Trimble ones. The main difference between the two is resolution and range. So MX50 up to around 80 meters. So that equates to about a swath of, let's say, 150 odd meter swath. Whereas with the MX90, you have a much larger range, longer range scanner, and your swath is obviously wider as well. You also have a much denser solution. And the IMU you pick is different. In the MX90, it's the high top of the range AP60 plus, whereas in the MX50 we have a choice of the AP20 or the AP60 depending on what you want to do, and the MX7 is an AP15. And yeah, so just to give an idea of what the specs are of these solutions, and believe me, they are very, very, very efficient and incredibly accurate. I mean, I get more impressed every time I use these things. All right, have a look at some of the data. So this is an example from an MX90. So with the addition of some additional cameras on the MX90 as opposed to the MX50, you get different planar images. So you can actually focus your data down on the pavement if you're doing crack detection or something like that. And then you have slightly higher resolution cameras looking off to the right and left-hand side in the forward direction. Bottom left corner, some of the laser data, so you can see the density. These are just screenshots, but it gives you an idea of the density. It's real world, and that's not an image, that's points, millions and millions of points. Bottom right-hand side, you also, another deliverable is a full 360 panoramic. So this camera here, the Ladybug 6, has 360 degree and up imaging ability. So that's how you get the panorama. All right, and then on the software side, so of course, you know, we're out in the field capturing all this amazing data and driving at road speeds, and you can imagine the magnitude of imagery and laser point cloud information that you're capturing. We've got to have some really good software in order to process the data. And of course, there's someone that's not muted. If you wouldn't mind just checking that you're muted. Yeah, so you've got to have some amazing software to process your data, process the trajectory, and then start to extract out information in essentially, let's say, from a survey perspective, surveying in the office. I mean, you can literally go and, you know, extract the line work, classify your point clouds, take measurements. You can go mad. So if we look at Trimble Business Center, which is our core soft geospatial software, we can do. Okay, cool. Thanks. Sorry, guys. Yeah, can just please make sure that you're muted. All right, on the software side again, so complete survey workflows in Trimble Business Center, advanced feature extraction capabilities, GIS and survey layer works. We can read and write directly into Esri and third-party, party spelt without a T, apologies for that, third-party spatial databases, SQL, Oracle, ODBC, and so on. And that is similar in the Trimble AMX software as well. So later on, Dennis will show you some data. He'll run some stuff or some part of it in Trimble Business Center, as well as the TMX software, I think is in the publisher, just to show you the few neat little things we can do. and also to focus on some of the accuracy components, because I think a lot of people's questions are like, yeah, but how accurate are you when you're driving down the road at 30, 40 kilometers per hour? We're very accurate, and we'll show you later. And then, exporting your data into a GIS or into standard CAD formats, and even collaborating via Trimble Connect's cloud platform in order to share your data, and give your customers and your colleagues opportunity to take their own measurements, view the data, extract some insights, and so on. The next piece of software is the publisher, and so Trimble MX Publisher is a online collaboration platform that is there primarily for you to be able to share your data with your colleagues and customers in an online environment. And then there's no need to have expensive software running on your machine in order to see all this data. It's all in the cloud, in a web browser, and easy to use, fully functional, and so on. We also integrate directly into through some plugins into Esri and QGIS and Autodesk, Bentley, and in order to take your data and write it into that and to view it within an environment that you may well be used to. So if you're a Autodesk or Bentley user, you don't necessarily have to now go and change your whole workflow just to be able to use mobile mapping data. We can plug it in that environment for you as well. So it's the software, whether it's Trimble Business Center or whether you're using Trimble MX or the MX Publisher, fantastic software, easy to use. It pretty much does everything that you need today. All right, let's have a look at some applications, and that's always a good place to start. And if we come from a classic survey world where you're taking your GPS, your total station, and you're doing cross sections on a highway, probably not the place you really want to be today with all the crazy drivers around. But if you're looking at road infrastructure asset management, you're literally driving down the road at road speeds, collecting everything that's visible to the laser and the imagery at that time, and you're able to do some inspections, some analysis, some visualizations, and make informed decisions with accurate information. Digital twins and smart cities, and what you're seeing in the market today is obviously this massive transformation towards digitalization and representing environments inside the cloud, let's put it like that, making digital representations of reality, and then using that to run models and to use some AI and so on in order to plan, to govern and maintain your environment, and also, of course, to collaborate as well. And sharing of geospatial data. I know it's probably a term that's used many times, but a picture speaks 1,000 words, and absolutely does. And here we're now creating platforms where you're able to share three-dimensional data from your PC, essentially. Okay, well, oh, there we go. I missed the slide. Next one is to consider different applications in the utility space and even fiber to the home. I know in Europe today there's a massive drive towards fiber to the home, and using mobile data to plan, to assess the environment, to do some predictive maintenance, even to consider right-of-ways and considerations for where you would need to build some additional infrastructure, and so on. So there's a lot of opportunities, and as I said before, you can literally drive down the road and capture a lot of information. Yeah, there may need to be some infill with some other devices and so on, but you're capturing 80 to 90% of the environment from the comfort of your vehicle. Some other options, pavement inspection. So again, when it comes to, say, infrastructure or road management, you need to have a good way of evaluating the pavement itself and inspecting for potholes, looking at material quantities, even detailed documentation of the environment so that you can send your repair and maintenance crews out to the right locations to fix up challenges and so on. And even, yeah, like we've tried to build in a bit of AI and some predictability into the into the inspection routines that are in TBC. And the imagery you see on the right-hand side is actually an extract from Trimble Business Center today. And we're writing reports to industry standards and so on. There we go. So underground infrastructure management. I think I had a duplicate slide there. Apologies for that. Underground infrastructure management. So conduct thorough inspections of tunnels. So now I say underground. You're like, okay, well, Dennis is going to show you some pretty cool stuff later, and it is in a tunnel. So what might be going through your mind now is, yeah, but you guys use GPS. Well, we do, but we also can prove to you that if you're in a tunnel, and the tunnel we went through down in Cape Town was 4.2 kilometers long, we're still able to achieve centimeter accuracy on tied down to control within that environment, and there's no GNSS. So that's the importance of the DMI, and of course the IMU is you can work in underground environments. And I think Dennis will show you some pretty neat stuff from the tunnel that we captured back in 2022 actually. All right, so that was just trying to keep you guys in the loop of some higher end applications and things you can think about that outside of your normal survey or mapping routines, other things that you can get involved in with a mobile mapping solution. All right, so why do we use a mobile mapping solution? What are the benefits for your business? So if you consider a couple of things down the lines of efficiency and productivity, and of course cost effective, it's a rapid data collection solution. Absolutely, it's well automated, and there's not, these systems have advanced. I think the first mobile mapping system I was involved with was back in like 2010. So that's a good 14 odd years ago, and these systems have gone incredibly automated. A lot of the things you had to do to get the system to run 10 years ago, it was painful. Today, it's literally button clicking. But you have to set up your system perfectly in the beginning, and then the rest is pretty straightforward. So you have increased coverage, so you can able to cover large areas efficiently, reducing field work. So not necessarily no need for field crews, but it can minimize your field crews. Guys are going out just to do some infill work instead of doing the entire survey, for example. So if you've got a section of road to go and survey, and you need to do cross sections every 5 meters, for argument's sake, you can drive the section of road, tie it down to your control, and do your cross sections in the office, and then you can send out your field crews to go and pick up bits and pieces of the survey that may have been missed out, or there was a culvert or something you couldn't see from the camera or the laser, and it's really more infill work. So you're reducing your field work considerably. Improved data quality. I mean, we're having resolution of the data and the imagery, and the point cloud is very high, and so you're capturing a lot of information in a very short period of time. And all of that allows you to be, enhanced decision making. So you're able to make decisions better, quicker, and be more informed around what the environment is about. And also you're saving costs. You're not spending lots of time out in the field. Lots of rework and is not necessarily required. So a very, very cost effective solution. If we consider accuracy and precision, and as I mentioned already, Dennis will jump in and show you some of the accuracy components, as I think that's always a big question, especially from the survey market. It's very high resolution data sets that we're capturing, close to real-time data, so it's not necessarily real-time. You still have a bit of processing to do in the office, but it's near real-time at the end of the day, and it's very consistent. So your data is the work that the engineering teams have done in the background to make sure that the lasers and the imagery and the IMU and everything is integrated, the data is consistent and reliable. And if you're driving over a section of road today, tomorrow, and the next day, expect the same results. And that's the repeatability and consistency is amazing. It's versatile and adaptable. So a wide range of applications you can use it for, and we've spoken a few about those already. Infrastructure inspection, asset management, disaster response, urban planning, normal survey, mining, and the list goes on. Integration with other technologies. So, using a mobile mapping system to capture data that you're going to be using in a survey or in a remote sensing environment or reality capture. So there's a lot of integration ability across the market. It's adaptable to changing conditions, and mobile mapping systems, you can use them in high-risk environments like road highways, driving at normal speeds, and you don't need to risk people's lives trying to cross the road with a GPS and take cross sections and so on. So you're able to adapt the technology into different environments. Last but not least, there we go, safety and risk mitigation. So the data is collected remotely, and you're sitting inside your vehicle, and the system is capturing everything remotely. So it's line of sight, but it's not touch, so it's remote sensed. Early detection of hazards could be an example. So mobile mapping can help you identify hazards, structural defects in the roads, and so on. And improved situational awareness. So near real-time data for mobile mapping can provide valuable insights for emergency response and disaster management. And I say near real-time because you drive down the road or through the section that you're mapping, and then produce a 3D model or a 3D point cloud pretty quickly after the fact. All right, so that was the interesting stuff, and what is the system about? Why should we use it, and so on. What Dennis will show you now, well, in a few seconds, I'm just going to quickly go through the workflow, and then Dennis will jump in and show you some data. Just in a broad sense, how does this whole process fit together? So on the left-hand side, you'll see your tablet, and that's a snapshot of what the tablet looks like when you're in the vehicle. You've got a map view, you can see where you are, and you can monitor all the different components of the system, look at the imagery, the lasers, GNSS, IMU, and so on. And that's your control environment. You literally push the bottom button on the bottom right-hand side of to start and to stop. And there's a few routines you've got to go through before and after you finish your survey. Once you've done all the data capture, which in relative terms is the easy part, and the rest is also easy, so it's a really easy system to work. You need to download the data into our Office software, and today we processing the trajectory in Trimble Business Center inside, and POSPAC, which is the software from Planix who make the IMU, is integrated into Trimble Business Center. So it's a slick workflow within Trimble Business Center. So download the base data, process the trajectory within TBC. Then you will need to tie your data down to ground control if that is a survey workflow. If you don't need to, because it was it's got a less accurate mapping job that you're up to, you don't need to necessarily tie in the ground control, but you absolutely have the ability to do that. If you've got ground control in your environment, you'll see black and white checkered. You may have even seen them on the roads around your city today, because there's a lot of mobile mapping work going on. You might wondered what that was on the side of the road. Well, it was probably a control point for the surveyor to go and tie into. So we can bring in control, and we can tie down the whole mobile mapping data set down to your control, produce some really good reports to make sure that things are tied in nicely and so on. Once you've got everything tied down to control and registered, you then take the data, you then have the ability to now start to extract features, classify the point clouds, do the necessary survey work, whether it's extracting out center lines of roads and curbs and barriers and doing cross sections and whatever you want to do, volumes, you name it, you can do it. And if it's more, say, GIS orientated, you can write your data directly, as I've said before, directly into Esri through geodatabase connections, and or export out the data into other third-party formats. A couple to note: TerraSolid, LiDAR data package, Tobidot, very focused on road infrastructure, and then the other classic CAD packages or 3D infrastructure packages of the world, Autodesk, Bentley, and so on. And then the last component is obviously sharing as well. So you're then, whether you're using Trimble Connect's cloud platform, whether you're using the Trimble MX publisher, you're able to share and collaborate your data in relative ease. And you must remember that we're dealing with massive data sets here, gigabytes and gigabytes of data. And so sharing it is not necessarily that easy. We try to make it as easy as possible by utilizing the cloud and web interfaces. So there's no need to download specific software if you're the customer and you're wanting to view the data. You can look at it through the web. All right, so that give you a good idea of what the flow is. And now I think for the pretty stuff, we're gonna jump onto Dennis, and Dennis is gonna give us a live show. And after he's done, we'll open the floor to some questions, and if there are any, and then we'll wrap it up. So Dennis, I'm just going to stop sharing, and then you're welcome to share your screen. And
cool. Is it showing now?
Yep.
You can see. All right, fantastic. Well, thank you very much, Sean. That was a very good presentation of our solution. So, as you've said, it's always a question of, how accurate can you get with mobile mapping system? Because if you imagine, and as you also mentioned, that it composed of a lot of systems. You have the Genesis system, IMU system, camera system, you name it. And when you have all of these components and you want all of them to work together, and sometimes the result could be different, right? So what I have here, and if you can see my screen, so this is just to prove that our solution, the hardware and the software, actually works together hand in hand, that can give you a really, really accurate data. So, and in this data, of course, I'm taking this one here as the worst scenario, because we're using GNSS, we're using GPS, GLONASS, and all that stuff. Of course, we have to have view to the sky, right? But when you go to, let's say in this case, tunnel, now all of a sudden we don't have view to the sky and we don't have satellites, right? Okay, in maybe 60 seconds, maybe we can get away by using the IMU data. But in this example here, we have 4 kilometers of tunnel, right? And there's no way that you can cross that in less than 60 seconds. So somewhere along the line, your accuracy will drift, okay? So if you have control points, right? Just as you can see on the screen over here, the guys at, is it GeoAfrica, Sean, that did this?
Yeah, the controls. Yes,
yeah.
absolutely.
So those guys actually created controls. So this is now the tunnel. So they've created controls either side of the tunnel. So you have from this side here at the bottom and another one here on the top. So, and the distance of this control is around 320 or 325 interval from one point to the next, and so on and so forth. So you can see this around 4 kilometers. We have around 12 pairs of controls. So basically what I've done is I used the, as you can see, this blue color line, that's basically the trajectory line of the MX50. And the points on the right-hand side of the line, that's the one I use to tie down or to adjust the data, right? The mobile mapping data. And what I've done is the point on this part of the line, as you can see from here, I use that as a checkpoint. Okay. So now just to check how good the data is let's go ahead and look at the cross section of this point cloud. And let's also check one of these points. So I'm doing live. So in some cases, as you well aware, when you do live, things could go wrong, right? Terribly wrong. So I'm hoping that it won't happen this time. Anyway, so you're looking at the cross section, right? And this point here that you're seeing, where I'm zooming now, is the checkpoint. So I keep zooming so you can see how well it is fitted. So I'll just take a measurement here from this point, okay, and to one of these points somewhere. Maybe this one here is a little bit farther, but I'll take that. So what we're interested here is to see is how good is the vertical accuracy of this thing, right? Considering that there is no GPS now inside the tunnel, right? You see the number shown because it's a little bit small. So can you read the vertical that I highlighted?
Yeah, it's 4.9 millimeters.
There you go. So okay, so maybe that's just in the beginning of the tunnel. So what I'll do is I'll take another example somewhere in the middle. So definitely around 2 kilometers in, there won't be Genesis signal, right? So by that time, the accuracy from IMU or inertial system has already drifted. So what I'll do is I will go ahead and select that again. So now we have here PDC or PED05C, which you can see from here now, right? So again, I'll take a measurement of that, okay, and then just pick one of these points over here. And you can see from here, the vertical accuracy is
That's just over
zero
5 mils.
5 millimeters, right? So we're looking at vertical. Um, so what I'll do is instead of measuring one by one, right, I could actually, and this is also to show the power of TBC. So what I've done is I've created a surface on the bottom part of this tunnel. And what we can do is we can just measure the points to the surface and then see how accurate these points are in relation to the surface, right? If I can move this bar, yeah, there you go. If I go here, measure to the surface, right? And then let's go apply. So from here, we can see all the points, but what I'll do is I'll create a report for that so we can see it better and bigger. There you go. So I guess you can see shown right from the right hand side, all these numbers that corresponds to the difference between the actual point itself to the surface model, which is the point cloud, essentially or basically, right? So it's all within, well, except from this one here, around 1 centimeter, 1.2 centimeter. But I think this is the part where I did not include the opposite side of that point as a control point because I couldn't really figure out where that is. But again, as you can see, it's all within less than centimeter, I would say, vertically. So now this just proves that, you know, if you have a really, really good control points, you can adjust your mobile mapping data observed from, you know, worst condition. So this is the tunnel, but of course you can go to the cities like that with high-rise building and so on. And again, if you don't have a lot of GPS, GNSS, all you need is a good control point. So of course it's garbage in, garbage out. So if you don't have a good control point and you use that in the adjustment, then you will not get a good result. In this case, kudos to these guys, GeoAfrica, for really having a good control point in this area here. So now that all of these data are already registered, or we call it, or we say adjusted, now we can start all of this data collection or extractions that you can do. And of course, we have a lot of semi-automated or automated kind of workflow within Trimble Business Center. And probably that's another topic that we can do. And maybe we can do another webinar in the future, Sean, that only shows all of these functionalities, what we can do from TBC. But
absolutely, that's the next step, Dennis. Good
yeah,
one.
yeah. But what we normally say is that use the Trimble Business Center, the TBC, for civil works kind of application. Yes, you can do GIS here also, but if you really want a good, fast GIS extraction tool or software, then you can go and use the Trimble MX software. So this is now what you're looking at here in the on the screen. So this is the entrance of the tunnel. This is the panorama that you're looking at. We have the point cloud. You can also put the point cloud here. Now you see we have the point cloud. You can do some measurements. Let's say, let's click distance here. Let's say from the top of this, what is this thing shown? Is this a GSM antenna or something?
That's a lamppost.
Is it? Oh,
Yeah,
okay.
yeah.
It's like a, okay. So you can see that, you can quickly measure something like that. So now, if you really want to do, let's say, a semi-automated kind of measurement, so let's say, let's go inside the tunnel over here. So here I've actually done some measurements already. And you see these red lines? These are measured and saved into what we call SQL database. I'm using the Postgres, but anyway, that's another topic that we can discuss later. But let me just turn them off so that I can do some measurement on top of that. So from here, I mentioned about semi-automated measurement. So here, let's say if I just want to measure, let's say that ridge or curb line, right? So you see how quick that is, and that in one click, it gave me 610 meters of curb line, right? That's just one measurement. I could also do multiple measurement in one go. So let's say from here, another curb line here, maybe in one at the bottom. Oops, sorry about that. Not that. One here. Okay, let's double click like so. See that? So two curb lines in just 2 clicks or 3 clicks, right? You can do that, from here, let's say, or here, or maybe here the same way, right? So it goes just like that. There's many more other features that you can do from here. Anyway, so that's another extraction thing that we can do in the future. But I just want to touch on the other part of the workflow that Sean has presented, which is the sharing. Because again, as Sean mentioned, when you're measuring or capturing data from or using mobile mapping data from mobile mapping systems, sorry for that. And because you can capture even up to 110 kilometers an hour, you can basically get millions and millions of point cloud, a lot of point cloud. So if you don't have a lot of people to process the data, then it could be an issue. But here we can share the data to other groups of people, perhaps to other department or to other branch of your company, right? So what we have here is here is the same data put into we call it intranet. So basically, we install a server or web server into your own computer at your own network system at your office, not in the cloud, although we have an option to put this in the cloud. So, but from here, it's basically within your own organization infrastructure. From here, you can now view the data using this is just a Google Chrome browser, right? And then from here, you can do all of this measurement. Okay, the difference is that when you do it from here, it's all manual now. There's no automated measurement. like what I've shown previously. But at least here you can also do manual, let's say the one that I did earlier, from the point cloud to the ground. And you can save this to, again, I mentioned earlier, Postgres database, or you can just save this into, let's say, when I save it, you can put it into KML. KML is, what format is that? That's Google Earth, right? So yeah, so this is the part where you can share the data. You can put it into ArcGIS or QGIS. If you don't want to pay the cost of policy of QGIS, then you can put it in the QGIS and still be able to get this data directly from the publisher. And I think that's it in the nutshell, showing the accuracy using different software to extract your information and sharing. That's
Brilliant.
it from me.
Thanks, Dennis. That's fantastic. So all the good stuff that I was talking about, Dennis has just shown that it's really true. So let me quickly just share my presentation again, and then we'll be good to go there again. All right, so just a couple of final words, and first of all, thanks, Dennis, for stepping in and showing all the good stuff, and showing that what we say is actually real. And I think it goes a long way, because and especially when it comes to accuracy, and guys like you driving at road speeds, how can you get that sort of accuracy? Well, we can, and that's important. So the data is trustworthy, tied on control, using the right survey methods, and so on. Yeah, so I hope that this presentation has been valuable to you and has opened up some questions in your mind about different ways of doing survey today or mapping, and maybe gives you opportunity to consider these types of solutions to enhance your business. And yeah, so thank you so much for joining, and thanks again to Dennis for stepping in, and to the Optron team for getting the slides all prepared, Stephen and Bron for setting up the webinar and the interface, and yeah, and thanks to you guys for attending. It's really great to have you here. So, just before we head off, any questions? You're welcome to unmute yourself and ask live, or drop in the text box or the chat box. Bron, did you get any questions during this session?
No questions, but I do have a hand up from Vincent. Vincent, you can unmute and ask your question.
Yes, thanks guys for the presentation. I just want to check how much should we expect this kind of a system to cost, and do you guys provide training for the operation and the processing of the point cloud?
Okay, absolutely. We are from field to finish in terms of training, support, and all that. So that absolutely we got guys there that have got a tremendous amount of experience in the mobile mapping world, and not only in the mobile mapping world, in all the products we provide. So absolutely feel secure that there's support, training, and service right there. So on average, if you're looking at an MX50 today, and you're including all the software and training and everything, you've got a budget on somewhere and you hope that the rand dollar exchange doesn't go really bad. You're probably in around 6 million rand excluding VAT, just to give you a ballpark. That's an MX50, middle of the road. MX90, you're north of 10 million. And then the MX7, which is the camera-based solution, somewhere around the 2 million rand mark. So that just gives you an indication of where you're at. So one thing that's important to keep in mind is all the fancy automation and quick feature extraction and so on relies heavily on the LiDAR. So if you just have an image-based system, it's a very manual approach. with LiDAR integrated, opens the door to automation and AI and all that, and all the cool things that Dennis showed you just now. Does that answer your question?
Yes, it does. I have another one.
Sure. I thought you hesitated for a second, so I thought you'd fallen off your chair.
No, I just want to check. Do you guys provide, how can I say this? Because you find that I've got a 90-kilometer road to survey, and using a GPS would take forever. And I don't have 6 million to spend on a software on a hardware like this. Do you guys provide an option of once-off service?
So we don't provide the service right now. Our focus is, of course, distribution. So we don't provide the service, but there are a bunch of folks out in the market. Are you from South Africa? Yeah, Vincent? There are a bunch of folks out. Okay, cool. There are a bunch of folks out there, and we can chat offline if you like, who have mobile mapping systems and can certainly help you out, get you in there. We do have a demo system, so we absolutely can do some demos and so on, but we don't do the paid for service today. That's for service providers who are in the market, actively doing this as a service provision. So we're not a service provider, we're a distributor. But we'll support you in whatever way we can. So drop us a line if you're interested, and we can keep chatting. It's no problem.
And in terms of training, Vincent, I would love to go down to South Africa again. So yes, please.
No, jokes aside, Vincent, drop us a line and we can absolutely put you in the right direction if we can't help you in terms of service, but we'd be happy to chat for sure.
Sean, there's also a request for your email address, so I have posted that. And then Vincent, you can obviously contact Sean using that email address.
Yeah, there we go. Last slide. Forgot to push the arrow key. There's my email address, and you're welcome to drop me a line anytime. All right. All good. Thanks, everyone. Take care.
Thank you.
Keep safe.